Welcome to another Level 3 probability distributions video. This is about the rectangular distribution. Now, some distributions take on a uniform or rectangular distribution shape. It's got to be continuous distribution, which means data that is measured, and it takes the shape of a rectangle because the probabilities are the same, or we say uniform, for all intervals. Here are the parameters for rectangular distribution. We have a value of A, the lowest value, a value of B, the highest value. We have the height of the rectangle, and there's a little formula that's provided on your formula sheet. To work out the height, we go 1 divided by B minus A. And we have the area inside the rectangle. Again, we know the area of a rectangle is base times height. So the base is going to be B take away A, and we're going to multiply that by the height. But you need to know that the area inside the rectangle is always going to be 1. It represents 100%. So the area inside a rectangular distribution is 1, just like we haven't talked much before, but the area underneath a normal distribution curve adds up to 1. And it's the same principle as the area inside, well, I say area, I mean probabilities inside a distribution table. Area and probabilities represent the same thing in probability. Finally, we have a parameter called the mean, and the mean we know is the average, and it's just going to be equal to B minus A all divided by 2. Let's get into our example. A lawyer has told his client that they're going to ring them sometime on Tuesday between 2 p.m. and 7 p.m. Now, because they said sometime between 2 and 7, we're going to assume it's a rectangular distribution. There's a uniform or equal chance any time between 2 and 7 o'clock. So our lowest value is 2, representing 2 p.m. The highest value is 7, representing 7 p.m. The height of the triangle, let's work that out. The formula is 1 divided by B minus A. So 1 divided by 7 minus 2, which is 1 divided by 5, and that gives us a decimal of 0.2. So the height of this rectangle is 0.2. Now the area, let's do a quick check. The area does add up to 1. We know the area is base times height. The base is 7 minus 2 and the height is 0.2. And when we multiply base and height, we get an area of 1, which is what we want. And finally, let's work out the mean. Well, that's just the formula B minus A divided by 2, which is 7 minus 2 divided by 2, which is 2.5. What does that tell us? That tells us that the mean sits right in the middle of this rectangle, and it's 2.5 units or 2.5 hours from each side. Let's ask some questions. Here we go. Part A. What is the probability the lawyer will call before 4 p.m.? To work out probability with rectangular distribution, we just work with areas. So let's draw a box between 2 and 4 o'clock, and we're going to work out the area of this box. We know the area is base times height. The base is 2 hours long, which is 4 take away 2 is 2, and the height is 0.2. So we multiply the base and the height, we get 0.4 for the area. So we can say the probability that they're going to call before 4 o'clock is 0.4, which represents 40%. Part B, what is the expected time the lawyer will call? Well, expected time is the same as a mean or average. And we've worked out the mean to be 2.5. So if we add on the mean to the earliest time, 2 o'clock, 2 p.m. plus 2.5 hours gives us 4.5 hours, and 4.5 hours represents 4:30. So the expected time is they should call around 4:30. And finally, part C. The client has to pop out from 3:15 p.m. to 3:45 p.m. to pick up their daughter from school. What's the probability the lawyer will ring whilst the client is out? Well, again, we're talking about areas. And we've got a really small rectangle here, which is between 3:15 and 3:45. That 3:15 to 3:45 is 30 minutes. 30 minutes is equivalent to 0.5 hours, half an hour. And so we just need to go base, which is 0.5, times height, which is 0.2. 0.5 times 0.2 is 0.1. So we can say the probability that they're going to ring while they're out is equal to 0.1, which is the same as 10%. Right, thanks so much for watching.